All right, so in that last video, I described how we could think of volume as taking this kind of area of the base layer times the height of the object. So what we can do is look for this shape, and kind of tricky to describe, but it's this shape that will repeatedly show up. Like what I often do is I think of our shape like a cake, and if I sliced into it, I kind of want to find this spot where if I slice into it, no matter where I slice, I'm seeing the same shape come through. So what I mean by that is, and with a rectangular prism like this, it's kind of easier to do. Like no matter where I cut, I'd be getting a rectangle coming through. I'd have all these slices that are rectangles. Where it can start to differ is when we change our shape. So let's say I cut down from the top here and I cut a slice like this, then like this, then like this. Notice how those shapes are all kind of changing, different lengths, widths. The person who gets this edge piece is kind of cut short because the person that gets the middle is going to have this massive piece. So that's not quite what I'm talking about, but imagine if I cut in this direction. If I started cutting the cake like from the bottom up, what I would get is all these circular discs, and they'd all be the same size. So that's what I'm talking about here, is kind of thinking of this cut that's going to be the same no matter where I do it. It'll have the same shape. In the case of a cylinder, that shape that's coming through is a circle. And so that would be our base layer for this one. When we deal with circles, this kind of base layer, when we're dealing with cylinders, this base layer that comes through is a circle. So if I think of this kind of base down here of just this kind of one slice, we're getting this circle coming through. And then what we're seeing is that then that's going to be repeated for many layers. And that number of layers that's coming through relates to the height of the object. So the height of the object is coming through along here, this straight line. Similarly, we can see that here, and our base layer is this rectangle that's length by width. So we already talked about the volume for our rectangle, but it's the idea that you could take that length times width, and then to make it three-dimensional, you multiply by the height. And that would give you your volume for a rectangular solid. So for a cylinder, we're thinking of the same thing. So we're thinking about this base layer that's a circle. So I'd want to use the area of a circle, which is pi r squared. So I would take pi r squared, and that would find the area of the circle, or I could think of it as the area of the base. And then to make it three-dimensional, I want to multiply by the number of layers, which I'm seeing, which is the height. So then we would just multiply by height, and that makes it three-dimensional. And that right there is our volume for a cylinder. We're taking a circle, which is the base, and then multiplying it by the height to see how many times are we getting that circle layer coming through. So if we relate this back to that can of green beans, where we have this height of 4 inches and a radius of 2 inches. So let me just draw this out so we have kind of a picture to work with. So we have this radius of 2 and this height of 4. So you could do is think about this area of a circle with a radius 2. So for volume, we would take pi r squared. And then to make it three-dimensional, we want to take that circle, and I think of it as just repeating the number of times or the number of layers that matches up with our height. So we go times 4. And if we plug that into a calculator, we should get 50.27 inches, and then our units here are cubed, because we're thinking in terms of cubes now with volume. Sorry, let me just show you that plugged into a calculator. So we'd have pi times r squared times height, and there's our 50.27. All right, let's look at one more example with the cylinder. So with this case here, we have a diameter of 6. So all the way across the can is 6, and height is 5. So if we have a diameter of 6, then we want to change this to radius so we can use our formula. So we just take that 6 divided by 2 for 3. So for volume, we're taking pi r squared and then multiply by that height of 5. And with that, we go to our calculator. So pi r squared times the height, 141.37. And we'll take that as centimeters and our units cubed.